Hello friends, welcome to engineering tutorial. So in the previous video related to electricity, the basic concepts about electricity, we discussed about electric potential energy, okay, and its mathematical expression we derived step by step. So in this video we are going to discuss about electric potential, which will be obtained from the expression of electric potential energy, okay, by following the definition. Okay, so electric potential, as I said, it is obtained from electric potential energy. It is a quantity which is used to describe, okay, the characteristics of the electric field, okay, to quantify the nature of the electric field in terms of a number, okay, in any region of space at any point. So it is a scalar quantity, okay, although electric field is a vector quantity, but electric potential, it is a scalar quantity. Okay, now let us try to understand electric potential and try to find out its mathematical expression. So again we will consider a two charge system. Okay, let us say we have a system, okay, where we try to move a test charge from point A to B in the presence of a electric field subjected by another charge. And let us say it has a potential energy equal to UA, U subscript A at point A, and it has a potential energy UB, a final potential energy when it reaches B. As it moves from A to B, there is a change in the potential energy from UA to UB. Okay. Now we know that the electric potential energy, it is given by this. Okay. The electrical potential energy for a two charge system, okay, for a two charge system, one fixed, another movable. When the movable charge it moves for a particular separation r, the electric potential energy is given by this expression q1 q2 by 4 pi epsilon 0 into 1 by r. I've already discussed about these things in the electric potential energy video, so you please check out that video. Okay, so as this test charge which is present in the electric field, it is moved from A to B, some work is done on it and there is a change in the electric potential energy, which is the negative of that work. Okay, follow the definition. Remember the definition of electric potential energy. It is the negative of the work done to move a test charge from one point to another in an electric field. So when it is moved, there is a change in the potential energy. Now the electric potential, okay, the electric potential difference between the 2 points A and B is given by the net change in the electric potential energy, that is UB minus UA, that is final potential energy, electric potential energy, minus initial electric potential energy divided by the test charge itself divided by Q. So the electric potential difference between point A and B, okay, the potential difference between point A and B, VB minus VA, is equal to UB minus UA by Q, which is the change in the electric potential energy as the charge is moved from A to B, the change in electric potential energy as the charge is moved from A to B divided by the charge itself, the magnitude of the charge itself. Okay, so always remember, this is the electric potential difference, the mathematical expression, which is the change in the electric potential energy when a charge is moved from an initial position to a final position divided by the test charge itself. Final potential energy minus initial potential energy divided by the magnitude of the charge. Okay, now the electric potential, the general expression, the electric potential at any point P in space, it can be represented as Vp which is the potential at that point. In that case, we have to consider a reference point where V0 is the electric potential at that reference point, U0 is the electric potential energy at that reference point. So again, as the the test charge is moved from that original origin or reference point to that point P, there is a change in the potential energy final minus initial UP minus U0 divided by the test charge Q. Okay, so this is the mathematical representation of electric potential. So if we try to define electric potential, we can say that the electric potential at any specific point P in space is equal to the change in electric potential energy per unit test charge. Per unit test charge means that change in electric potential energy divided by Q, the test charge, magnitude of the test charge, when it is moved from any reference point or origin or anything, any fixed point which we decide to consider as reference and make all the measurements with respect to that specific point P. Okay, or it can be written in another way as the work done per unit test charge when by an external agent when it is moved from any reference point to point P. We know that the electric potential energy is the negative of the work done to move a test charge in the electric field. So there are two ways to write the definition of the electric potential. You can note them down. But always remember this expression. The potential difference between any 2 points is, let's say, A and B. The potential difference between point A and B, that is VB minus VA, final minus initial, is equal to the change in electric potential energy, final potential energy minus electrical potential, initial electric potential energy divided by the magnitude of the test charge. Okay, so here we have discussed about the electric potential. Now let us try to correlate electric field and electric potential, how they are related with one another. For that, let us consider we have a charge distribution, a positive charge distribution, and we have a small test charge Q. So obviously there will be a force of repulsion. The positive charge distribution, it will try to push the small positive test charge Q away from it, and there will be a small displacement. Okay, the separation between them, let's say it is R, and there will be a small displacement dr, let's say. So now we know that the electric force, it is given by F is equal to QE. We know that E is equal to F by Q, electric field is equal to F by Q. So force is the test charge multiplied with the magnitude of the electric field. F is equal to QE. So the work, we know that force into displacement. So the small amount of work dW done to move the charge over a small distance dr will be dW is equal to FdR, which will be equal to QE into dr. Okay, we substituted this value, F is equal to QE here. Okay, now the electric potential energy is the negative of this work done. We have studied this definition, this concept in the electric potential energy video. Okay, you please watch that video first, then try to uh, watch this video because it is interrelated. Okay, so in the electric potential energy video, we've discussed that the electric potential energy is the negative of the work done to move a test charge from one point to another in an electric field. So which is minus QE dr. Okay, we substituted this dW value, dW is equal to QE dr here, minus QE dr. Now the electric potential we just discussed here right now, that the potential difference is the change in potential energy divided by the test charge Q. So the change in electric potential is the change in potential energy divided by Q. So we'll substitute this minus QEdR here in the numerator. So it will become minus QEdR by Q. Q and Q will get cancelled from both the numerator and the denominator. And the small change in electric potential will be minus EdR. So the net electric potential V will be minus whole integration of E dr. So this is the relation between the electric potential V and the electric field intensity E. Now we know that electric field is a vector quantity. So, and the displacement, it is also a vector quantity in a particular direction. So it will be in vector form represented as VR vector is equal to minus E vector and dr vector. Okay, whole integration. So this is the relationship between electric field and electric potential. So here we have discussed about electric potential. We derived its mathematical expression from electric potential energy, and we also studied two definitions in terms of potential energy change and work done. And then we correlated, found or established a relationship between electric field and electric potential. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.